In this video, we're going to be looking at average cost and marginal average cost. So when we are looking at a cost function, so let's say if C of X represents the function of the cost to produce X items, then the average cost to produce that many items. Well, when we think about what we usually do to take an average, we get the total of a bunch of values, and then we divide it by how many values there were. When we're looking at an average cost function, it's a similar process. We take the total cost function and we divide by the number of items that were produced. And that's the function that defines average cost. Now, the symbol that we use to represent the average cost function and differentiate it from the regular cost function C of X is we put a bar over the C. Okay, C bar of X. So that represents average cost. And we get the average cost function by taking the cost function and dividing by X, the number of items produced. Marginal average cost then is represented by C bar prime of X. So basically, we find the derivative of the average cost function, and that gives us marginal average cost. So let's take a look at this in action, and I'm actually going to borrow a problem from your textbook because I'm really bad at inventing these off the top of my head in ways that will work out logically and make actual sense. So if we I'm grabbing checkpoint 7 from section 11.6, and here we have a cost function given by C of X is X squared plus 2X plus 5 over X plus 1 plus 1,000. So we have C of X, X squared plus 2X plus 1. Is that what I said? X squared plus 2. Oh, no, sorry, plus 5 over X plus 1. Okay. Plus 5 over X plus 1 plus 1,000. And here's our example. And we want to find average cost and marginal average cost. Okay. So, average cost, the first part, again, C bar of X, we want to divide that entire function by X. Since the first part of our cost function is already written as a fraction, sometimes it's easier to think of it as multiplying 1 over X times all of the terms in the cost function. And a lot of times the thing that gets trickiest with these is just trying to get everything looking as simplified as possible. Just, because it's going to be easier when we think about finding the marginal average cost, the second part of this problem. The simpler our average cost function looks, the easier it's going to be to find the derivative. So it does actually benefit us at this point to try and make this look as simplified as we can. So let's see what we can do here. We are going to have, let's see, let's look at this as, so we have x squared plus 2x plus 5 over x times x plus 1, right? Since we're multiplying two fractions here, I can simply multiply straight across the top, straight across the bottom. 1 times the numerator is just the numerator. X times x plus 1 in the denominator, I left it in factored form, okay? And then here we have plus 1,000 over x. Now, if I want to be able to add these two together and make a single function that is one fraction, I need a common denominator, right? I can't add these together the way that they're written. So to get a common denominator, looking at the denominator here, it's x times x plus 1. So what this denominator is missing, the 1,000 over x, it's missing an x plus 1. But in order to avoid changing that fraction, if I multiply by an x plus 1 in the denominator, I have to multiply by an x plus 1 in the numerator. So now I'm really multiplying by what amounts to just a fancy looking 1, right? This whole thing right here, that's equal to a 1. So I'm allowed to multiply by it without changing the value of that fraction, but then it's going to enable me to add these two things together. All right, so when we distribute the 1,000 here, we'll end up with 1,000x plus 1,000. So I'm actually going to need to go over to a new screen here. So we're looking at C bar of x, or average cost. And then we had x squared plus 2x plus 5, x squared plus 2x plus 5. Whoops. Then I had plus 1,000x plus 1,000. Over x times x plus 1. And again, just thinking about simplifying this as much as humanly possible, we can distribute that x in the denominator inside the x plus 1, and we can clean up any like terms in the numerator. So we've got average cost is x squared. Then we have a plus 2x. We have a plus 1,000x. So that's plus 1,002x. Then we have a plus 5 and a plus 1,000. So plus 1,005. Whoops, that's not 1,005. That's 10,005. Let's fix that. There we go. Over x squared plus x. And there is our marginal cost function, as nice looking as we could get it. If there were any common factors in the numerator and the denominator, we could factor those out, but in this case, there are not. Now to find the second part, to find the marginal average cost, we're going to need to take the derivative of the cost function, the average cost function rather. And I think you can see now why they put average cost and marginal average cost in the same section as the quotient rule, because to find the derivative of this function, we're going to need to use the quotient rule. So the quotient rule says, take the denominator function, x squared plus x, multiply by the derivative of the numerator function. Okay, so the derivative of the numerator function, the derivative of x squared is 2x. The derivative of 1002x is just 1002. And the derivative of 1005, because it's a constant, is 0. So that's denominator times the derivative of the numerator minus the numerator, x squared, plus 1002x plus 1005 times the derivative of the denominator, which the derivative of the denominator here, x squared, that's going to be 2x. Derivative of x is going to be plus 1. And then all of that is going to be over the denominator function, x squared plus x, quantity squared. And then again, at this point, you're just trying to get this as nice looking as you possibly can. So for this first set, we will need to FOIL because we're multiplying together two binomials. So we have the x squared plus x times the 2x plus 1002. So if we do x squared times 2x, x squared times 2x is going to be 2x cubed. When we look at the outers for the FOIL, we have an x squared times 1002. So that's going to be 1002x squared. If we look at the inners, that's these here. X times 2x is going to be 2x squared. And then the lasts, we have x times 1002. So that's 1002x. Then when we go back over here, we have this negative in between that we're going to need to distribute through. But it is actually really handy to do the foiling first and then distribute the negative. So if we are to, or not FOIL, in this case it's going to be multiplication of polynomials because this first quantity here has 3 terms. So first thing we need to do is distribute the 2x through to everything. So we would have 2x times x squared, and I'm actually going to do this in a different color so that hopefully you can see it a little better. So 2x times x squared is going to be 2x squared, or sorry, 2x cubed, not squared. There we go. 2x times 1002x is going to be 2004x squared. 2x times 1005 is going to be 2010x, 2010x. And then we're going to have the plus 1 that distributes through. So that is going to give us a plus x squared. Man, I'm running out of room here. Sorry, I'm going to have to go up this side. Plus x squared plus 1002x plus 1005. But all of that is being subtracted. And so that negative is going to propagate through all of that. So we will have a negative 2x cubed minus 2x cubed. Then we will have a minus 2004x squared. Then we will have a minus 2010x, minus 2010x. I am so sorry. I'm going to need to like squash this end part on. Then we have a minus x squared, minus x squared, minus 1002x, and then we have a minus 1005. Okay, so that's all of that. Goodness. And then we're dividing by x squared plus x quantity squared. So x squared plus x quantity squared. Okay. Whew. Deep breath, right? That was a lot of stuff. So marginal average cost is equal to, now we're looking for things that we can cancel. Well, I've got a 2x cubed and a negative 2x cubed. I've got, let's see, anything else that cancels? Yes, I have a 1002x here and a 1002x there. Those are x squared. Okay, I think those are all the things that cancel. So now I'm just looking at combining like terms. I have a 1002x squared. I have a 2x squared. I have a 2004, or sorry, a minus 2004x squared and a minus x squared. So 1002x squared plus 2x squared, that's 1004x squared, minus 2004x squared is going to be minus 1000, minus an x squared is going to be minus 999x squared. Then I have a minus 2010. Let's see, that took care of all of these. Minus 2010x minus 1005 over x squared plus x quantity squared. And that's probably about as tidy as we need it to be. If you really wanted to FOIL together the binomial in the denominator, you could do that. But that's what we're looking at for our average marginal cost formula.